Welcome to this session, Introduction to Deep Learning. I am Dr.P.S.Eliahim Jeevaraj, Assistant Professor, Department of Computer Science, Vishayaper College, Tiruchirappalli. So, deep learning is a catchy term in a computer field. So, lot of LLM models and Chat GPT, then Gemini, Copilot, and so these LLM models are built on deep learning. So, the deep learning is a subset of artificial intelligence. So, artificial intelligence is a technique to mimic the human behavior and it instructs the machine to learn the human intelligence. Machine learning is a subset of artificial intelligence. So, machine learning that employs the statistical methods and to learn the patterns in the data sets and make the models for the machines. So, deep learning is a subset of machine learning. So, it built on the multiple layers. The basics of deep learning is artificial intelligence, artificial neural networks. The basics of deep learning is artificial neural network. The artificial neural network, it is mimic the human nervous system and the brain. So, this artificial neural network is encompassed by the multiple layers. The layers are input layers, hidden layer and the output layer. The purpose of input layer is to get the input from the real world and send to the input to hidden layer. The hidden layer, it processes all the information and it sent to the output layer. So, output layer, it gives the inference to the for the real world problems. The main purpose of activation function, so it enables or it determines the output of the every neurons except the input layer neurons. The word deep, the deep means it consists of multiple layers. The deep learning, why we have to choose the deep learning? The traditional machine learning techniques or the models that can be crafted the features by manually. So, that has the disadvantage of incomplete and inconsistent. So, it makes the problem in classification problems. It makes the problems in classification. So, that is why we have moved on to the deep learning. So, deep learning, it is a so the feature extraction and the classifications, so both are embedded in this layers. So, we will get the classification output directly once we can get the input and we can process, we can embed the feature extraction, the classification, and we can get the output. The convolution in a deep learning, the main architecture, that is a convolution neural network. The convolution is a mathematical function that is employs the point-wise multiplication and it produces another function. This convolutions, it extract the features from the images, the features like line, edges and the points that can be convolved by convolution property. So, the output of the convolution property is the feature map. That feature map can be employed to the dense layer and it produces the classification. This convolution neural network has 4 layers. One is a convolution layer, RELU layer and pooling layer. Finally, we have the fully connected layer. The purpose of convolution layer, it detects the features from the images. The convolution filter is applied on the images, the entire images. Once we can apply the convolution layer, then finally we have the feature map. The convolution layer has the parameters of filters and the size, stride and the padding. The filters it should be always in the square shape and it should be in the odd number size. The stride, the number of positions at the where filter stops. The padding, so we have to address the borders of the image. So that's why we have to add the padding in all the borders. The second layer, we move on to the second layer, that is RULU layer. The main purpose of RULU layer, so we have convert the feature map. In the feature map, so we have unnecessary features in the feature map, so that features can be removed by the RULU layer. So mainly it removes the negative values. Instead of the negative values, we can assign the zeros, then we will get the positive values. Finally, we have the third layer, that is pooling layer. In the pooling layer, the main purpose of pooling layer, so it reduces the complexity of feature map. That means it reduces the size of the feature map. So by reduce the size of the feature map, it takes less computational power. So it has parameters. One is a spatial extent, another one is stride. Spatial extent, the size of the pooling filter, that is, it may be the 2 by 2 or 4 by 2, 4 by 4. It should be in the even numbers. It has two strategies. One is a max pooling, another one is average pooling. In a max pooling, it takes only the maximum feature value. It focuses on only the maximum feature value. Average pooling, it focuses on average of all the features in the spatial extent. The final layer in the convolution neural network, that is fully connected layer, fully connected layer. So in a fully connected layer, it flatten all the features and make it as a dense layer. So that dense layer is sent to the feed forward neural network. So then in the feed forward neural networks, we have to employ the softmax function, softmax activation function for the classification. Finally, we will get the classification results, either the class 1 or class 2 or the class 3 or class 4 or class 5. So in the working of CNN, so it takes the input as images and it apply the convolution layer. By applying the convolution layer, we have to detect the features. Then applying the RULU, we have to remove all the negative values. That means we have to remove inconsistent features. We have to focus on only the positive feature values. Then we have to pool all the selected features by using either the max pooling or the average pooling. Finally, we have to flatten all the features. Then it's sent to the fully connected layer. In the fully connected layer, we have the softmax function. The softmax activation functions classified as either the x value. In this example, it is classified as x, letter x. So apart from the convolution layer neural net, so apart from this is the general architecture, we have the different models like LENet, AlexNet, ZFNet, GoogleNet, InceptionNet, UNet. So these are the models can be employed for image classification as well as the natural language classification problem. So today we have discussed about the fundamentals of deep learning and the layers of convolution neural network. This convolution neural networks finds the applications in image classification, in natural language processing, and it is the basics of building a LLM models. Thank you.